Okay, so these are the topics I'm going to cover. First, I will start with manual testing, and then automation concepts, and then Java. We need Java basically. Without Java, we can't develop use any automation tool. So I will teach you Java also. Then Selenium basics and advanced. Then I will teach you framework design and development. Under framework design and development, I will teach JUnit, TestNG, page object model, Maven, Cucumber, and hybrid framework. Finally, we'll discuss about DevOps tools. Under DevOps, I will cover Jenkins. Okay. Then you have to do project work. These are the modules I'm going to offer you. Starting with manual testing. Manual testing is mandatory, whether you learn automation or not. Okay. If you want to career in testing, first of all, you need to learn manual testing. You should know manual testing basically. So let's start with manual testing. Then we'll discuss remaining topics one after another. Yeah. We go from basics actually under software testing. First of all, what is software? Okay, software is nothing but a collection of programs, right? Where these programs will perform a specific task. Okay, in day-to-day life, in everybody's day-to-day life, we come across different type of softwares, right? For suppose you are using a laptop contains so many system softwares. System softwares means we are operating system, servers, utilities, device drivers. Okay, these are the various categories of softwares. Under these categories, system software is one of the category where we come across on day-to-day life. Device drivers, operating system, servers, and utilities. Then coming to programming software, every program, including Java, should contain these programming softwares. Why? As a human being, we can understand Java or our popular language called English, Telugu, or Hindi, but computer can't understand, right? These languages needs to be converted into another format. Those are called actually compilers, debuggers, and interpreters. These are the softwares act as mediators to compile, debug, and interpret. Okay, I'll tell you one simple example. Okay, here if you take any program language, it has a own standard. Okay, it has a own standard of syntax. If you take Java, just assume this is a Java language. Okay, in this Java language, this is a Java code. Okay, Java code. Okay, under this code, we'll write a class hello world inside this, and so on. We'll write so many things inside this. Okay, public void main. This is another method. Okay. Okay, this is another method. Simply write system.out.println. Others print hello world. Okay, this is a syntax. As a human being, we can understand this code, but when it comes to machines, operating systems, or hardware, they can't understand. This code needs to be converted into a byte code. Okay, this code needs to be converted into a byte code. How we are going to convert? Okay, so to convert, what we do, very simple. We need a compiler. Okay, this is where actually compiler came into the picture. Okay, this is a code compile. Okay. Yeah, the compiler. Okay. After compiling this code, what we are going to do? Okay. The compiler compiles your Java code. Okay. And then this code gets converted into a bytecode. Okay. Bytecode. This bytecode, as a human being, we can understand somewhat, but you can't understand fully. Okay. This is called actually a bytecode. This is a bytecode. And then again, okay, we need to use another very important component called interpreter. Interpreter will come here again. Okay, this is an interpreter. Okay, so this interpreter converts your bytecode into machine code. Okay, machine code. Okay. Code. And then machine code interact with the operating system and the hardware. Okay, there's a small interface here. There's a small interface. Okay, this interact with the hardware. That's it. Okay, very simple. If you write any program, first the compiler needs to be validated against the grammar. We can't write whatever you want in the Java program. Java program has its own syntax. Okay, you have to follow the syntax. After writing the code gets compiled basically. Okay, and generate a bytecode. This is also called actually, what is this called as? This is also called actually class file, dot class file in Java basically. Okay, class file. This class file again converted into a machine code. Here, we need a interpreter. After converting a class file into a machine code acts as an input to the JVM. Okay, I will explain when you are discussing about Java. JVM will take this machine code as input and execute that code on the hardware. That's all. This is internal logic of any programming. Maybe some of the program doesn't have compiler. Best example, Python. Okay, Python is an interpreter-based language. That means Python does not have any compiler. But when it comes to Java, Java has both compiler and interpreter. Along with compiler and interpreter, these are actually system softwares. We can't see it or naked eye. We can see Java code. We can also see .class file. But you can't see compiler, interpreter, and all we can't see. Okay. So interpreter, compiler, debuggers, all are actually programming softwares. Then coming to application softwares, what are the application softwares we have? Application softwares, right? Can you tell me a few examples of application softwares? What are the application softwares? Example, I'll tell you SAP. Okay, SAP is a application software. What are the other softwares we have? Okay, SAP, Oracle, okay, PeopleSoft, and then we also have Salesforce. They're actually application softwares. So in day-to-day, we are going to have these applications to access it. Maybe you may aware, I may not aware, but definitely in your life, I mean, as a technical guy, we come across these kind of applications. SAP is a ERP application. Oracle also database come ERP application. PeopleSoft is a CRM application. Salesforce is a CRM application. What is CRM, by the way? CRM means what? Anybody? CRM means CRM is nothing but a customer relationship management applications like front end, okay, front desk, okay, application where we enter customer details and then we handle customer queries, okay, providing customer services and all, okay. So those part comes under a CRM, okay. These are the application softwares, programming softwares, and system softwares. Then what is the role of software testing here? What is the role of software testing? Software testing role is actually to find out the bugs in the application. That is our main intention. Our main intention is pretty much simple and clear. We have to identify the bugs and errors in the application. Okay. So to identify the bugs and errors, we test the application thoroughly. So testing is part of a software development life cycle. As I told you, we have a process called SDLC. Okay, SDLC. Under SDLC, we have one of the phase called testing. Testing is one of the phase. Okay, testing basically tests the application and uncover the defects. That is the main objective. Okay, and deliver the quality product to the client. Why do we need testing? Yes, of course, we need to test an application. Okay, to ensure that software is bug-free, ensure that system meets customer requirement and software specifications, and we also ensure that system meets end user expectation. Fixing the bugs identifier after release is expensive. Okay, here these are very easy to understand. Okay, why we need to test an application? To release a quality software, and software is bug-free, ensure system meets the customer requirements and software specification, ensure system meets end user expectation, and finally, last point, fixing the bugs identified after release is expensive. Okay, how many environments we can see in our day-to-day life? Okay, what are the environments you can see? For suppose you are working in software industry, definitely you might come across with a different type of environments. What are those environments? The environments, okay, IT or application environments. What are those environments we have? Okay, first we have a sandbox. Okay, another one is actually dev environment, dev. Okay, and then we have a QA environment. Okay, QA environment, and then finally we have a pre-production. Okay, then finally we have production environment. Okay, so total how many environments are there? We have around 5 environments. First one is first one is a sandbox. Okay, and then it is dev environment, development environment, okay, and this is QA. This is QA or testing environment. Okay, this is a pre-production, and this is actually production environment. Production, right? Sandbox, development, QA, pre-production, production environment. What is this environment? First of all, see, I want to develop an application. Okay, I'm developing on my system. Okay, can we carry testing also on the same system? Can you give your system to somebody else to carry testing? That is highly impossible, one thing. Second thing, if both developer and tester works on the same environments, there's a quality compromisation. That means we are compromising at the quality. The testing team always should be independent. Okay, whatever the defects we are getting in the testing should be reported by the testing environment, not in the dev environment. Means the application. That's all. Environment is nothing but having the separate environment or a system or configuration for each and every phase. Sandbox. What is sandbox? What is sandbox? Anybody? Where?
Sandbox is nothing but lab or something environment.
Super.
Or yeah.
Very good. Lab. Okay. Where we try. Okay. New features. New features in the application. In the application. Okay. What it means? New feature in the application means. Okay. Nothing. Suppose you are implementing SAP. Under SAP, so far you have implemented okay, the database. That is a Oracle is a database we are using. Currently, SAP has come up with its own database called HANA. HANA is a database, you know, right? So it is the database built on its own. SAP has its own database right now. Okay. So currently what you have to do, SAP is recommending to run your applications on HANA database instead of Oracle database. So what you have to do, we have to gradually shift your backend from Oracle database to HANA database. How do we do? We can't do in one stretch. First, we have to check whether it is compatible to our application or not. How do we check? That is where we conduct exploring the features in the application, and then we do thorough analysis and compatibility study. Then finally we adopt the latest technologies, right? So sandbox environment is a kind of access, as you said correctly, it's a lab environment where we try with the new features in the application development. Then dev environment. What is dev environment? The name itself is telling the developer uses this environment to develop the code or implement the code. Okay, got it? Yeah. So first we explore the features, then we come to dev environment. After that, we go from dev environment to QA environment. Okay, QA environment. After QA environment, after thoroughly testing the application, we move to pre-production. What is pre-production environment? Who will use? These things, you know, dev means we are developing the code over here. In this environment, that means a separate server will be there. In that server, we have developed the application, we have developed the code and deployed it, and finally it is working fine. Then finally we are moving from development to QA environment. QA means tester. Okay, this is where we are focusing, right? Testing. So as a tester, we test the code in this environment. Once testing is done, what we do, the code moves to pre-production. Okay. So pre-production, where before going to deploy in a production environment, we have an environment called pre-production, where we carry certain type of testing. That is actually alpha testing. This is also called actually user acceptance testing. Under user acceptance testing, we have a alpha testing and beta testing. Under alpha testing, we check whether the application is ready for the production or not. Okay. Then finally production, where the end user, like if you take ICICI Bank application, this is an application, right? This is ICICI Bank application. Okay. So what is this current environment? The URL which I entered here, ICICI Bank. Okay, I'm able to see everything. What is this environment? Can you tell me?
Production.
Yes. Excellent. Okay. So the application which you are using here is in a production environment. Production means on day-to-day, okay, we are using the application, right? That instance is called as a production environment. Okay. The instance which you are using on day-to-day, okay, life, that is called actually production environment. Hope you are clear. Okay. So sandbox, where it's a lab environment where we try new features in the application functionality, and development, where development team will develop the code and test it here. Okay, there's one more thing here I want to make it clear. Here we conduct a black box testing. Sorry, white box testing. White box. I will explain what is white box, what is black box. Just remember this point. And development environment, we conduct white box testing. And QA environment, what we conduct? We conduct a black box and a gray box testing. Okay, and then pre-production, as I said, we conduct UAT. Okay, what is UAT? UAT means user acceptance testing. That's all. Okay, we conduct a user acceptance testing. Okay, production, this is where we conduct a beta testing. Okay, beta testing. So testing spread across all the phases. If you look at here, testing spread across all the environments and all the phases of the application. Here also we do, but the testing is very minimal here. The white box testing we are talking about, right? This is done by the developer itself. Okay. Yeah. Done by the developer. Okay. Developer. This is done by actual tester, also called actually functional tester. Now we are clear about environments. Are you clear? Yeah. Are you clear?
Yes.
Okay. This is sandbox. Development is I can say full red. Okay. Then QA environment we can say amber, and this is okay, lime color. Then finally it will go in a green, full green, right? Okay. So these are the environments we have. So let me know. We are testing here. Fine. This is done by the developer. This is done by the tester. Okay. This is also done by the tester. Somehow by mistake, you miss a defect here. What happens still? What happens? You miss a defect here. That means somehow you could not test or you forgot to test one feature, and then the feature has some defect. The defect means a bug is there. So basically you miss a defect here. In QA environment, as testing environment, you miss a defect. Now tell me what happens. So application is moved into pre-production with the defect, and again the application is moved into production with the same defect. Okay, if you fix a defect here, if you fix a defect in a QA environment, okay, hardly it costs you $1. Just assume, okay, it costs you $1. Only $1 it costs you. Okay, QA, it costs you $1. Okay, if you miss a defect and the defect moved to production in the production environment, if you want to fix it post production, it costs you $10. Now tell me which one is better. Fixing the defect in QA is better, or post production is better? Yeah.
QA. Yeah.
Correct. So why you can ask this question? Why, sir? Okay, QA is only $1. Production is taking $10. Why? See, because most of the application development happens in the cycles. If you miss a defect in one cycle, again we should be ready with another cycle. The same process needs to be continued in another iteration. Is called as cycle. So for each cycle, again development team should work, and operations team should work, and environment or configuration team should work, and testing team should work. And there would be a definite impact on the schedule. There will be a definite impact on the schedule. Scheduling means plan. plan gets impacted. Okay, so that is the reason fixing the defect in QA environment is much cheaper than a production environment. If you miss a defect in QA environment, that automatically move to production environment, and fixing the defect post production is very costly affair. So you should always fix a defect in a QA or a production environment. Sorry, QA environment, not in production. These are the application environments where we can see in a day-to-day labs, but not day-to-day. If you are working in software company, where we come to know these are the environments we have. Okay, sandbox, development, QA testing, pre-production, and production environments. So hope you are clear. Let me know if you have any questions. Everybody, are you guys clear? Okay, next. Since we are focusing mainly on testing, we'll discuss today what is software quality. Quality is basically justification of all the requirements of the customer in a product. Okay, as a tester, we are responsible to deliver bug-free and deliver the product on time, deliver the product within the budget, and we have to check the application is meeting the customer requirement and expectation or not, and the application is maintainable or not. Okay, we are responsible. These are the responsibilities of a tester. We have to deliver bug-free software. We have to deliver the software on time, and we have to deliver the software within the budget, and we have to meet the requirements on expectation, and then you have to maintain the application. Application should be in a maintainable stage. Okay, so next, coming to the difference between bug, error, and failure. What is bug? What is failure? What is error? Tell me who can answer this question. Bug, error, and failure. Okay, what is bug? So as I told you, if you find a defect, or a deviation in a functionality in a dev environment, I told you there are 10 environments, right? There are 3 environments: dev, and then testing, and then production. If you find a defect in a dev environment, defect, okay, some issue, we can say issue is called as actually error. Okay, same thing if it happens in a QA environment, QA or testing environment, it is called actually bug. Okay, and then finally it is a production environment. If there is a production, if there is an issue in the production environment, or there is a bug, then it is called actually failure. Okay, dev, QA, testing, and failure. So there's an issue, then in a dev environment, it's called actually error. If there is an issue in a testing environment, it's called actually bug. If there is an issue in a production environment, it's called actually failure. Okay, bug, error, and a failure. Are you guys clear now? Yeah. Why we have bugs in software? Why there is an issue in the software? Because there will be miscommunication, software complexity, programming errors, changing requirements, lack of skilled testers. These are the reasons for having bugs in the software. I will tell you one simple example. I worked for one of the South Korean client. Okay, they are into telecom. You know, right? South Koreans doesn't know English. Even Chinese people also doesn't know English. Okay. So what I have to do, there is a translator. Whatever we are going to deliver on day-to-day basis, there's a translator. He will translate from English to Korean. Similarly, translate from Korean to English. Okay. So what happened if he say there is some feature that is required for Korean customers? Maybe they have some very peculiar requirement for Korean customers that we are not aware completely. If there is a miscommunication between the client and the vendor, definitely we end up with a lot of defects in the or bugs in the software, right? Of course, right? If you can't understand the functionality of the application, definitely we end up with so many bugs in the software. Similarly, complexity also. If there is a complexity is very high in software, automatically we end up with so many defects and bugs. Errors also same. We have recruited 5 developers. The developers are not skillful enough in implementing the software. Definitely we end up with so many errors in the program, and directly it has a huge impact on the quality of the software. Changing requirement. Really, the fourth point is very, very important. Okay, because it causes a lot of defects in the software if you don't manage the changing requirements properly. You have to manage these requirements properly. Otherwise, we end up with so many defects. Okay. So what are those changing requirements? We are start developing the login functionality today for the banking application. Banking customers are 2 categories. One is a retail customer, another one is a banking, what you call investment customer. There are 2 customers, investment banking and a commercial banking and a retail banking. There are 3 categories. Suddenly there is another category bank wants to add. Okay, basically he is a NRI. So I want the bank want to provide NRI banking also. Suddenly NRI also have a certain privileges to log into the application. What we do? We have already developed an application. Suddenly there is a new requirement came. So first we have to do impact analysis. What are the modules get impacted with the new functionality? After doing thorough analysis and doing complete impact analysis, we have to start implementing the new changes. If you don't do thorough analysis and do impact, doesn't do any impact analysis, we end up with so many bugs in the software. And lack of skill test also, as I told you, fixing the defect in QA environment is $1. Same defect, if you fix it post-production, it costs you $10. First of all, what are the reasons to miss a defect in testing moment? If the tester is not skillful, if the tester is not mature or not experienced, then we end up with so many defects in the softwares. So these are the reasons to have bugs in the softwares. Are you clear now? I have discussed so far why there are bugs in the software, different environments in the IT application development. What's the difference between bug, error, and failure? And we discussed about what are the responsibilities of the self-tester. Why do you need a test? And what is testing, and then what is software? Okay. Let me know if you have any questions. Yeah, Nagendra, Swapna, Nilima, Apurva. Okay, then. If you don't have any question, that's fine. We'll stop here and we'll continue with the remaining topics from on Monday, Saturday.
Sir, one question is like, what is a defect and what is bug? What is the difference between defect and bug?
Defect and bug. Okay. See, what is a bug? Bug is nothing but it may also termed as a technical. Okay, for example, what you can say, what you call. For example, you have a code where it is supposed to be integrated with the Oracle database. Okay.
Okay.
Okay, then that can be termed as a bug. Bug can be any kind of issue during a testing life cycle. During testing, if you find any issue, it is called actually bug. Then what about defect? Defect can be termed as when there is a issue found in a production environment. Then that is termed as a defect. Okay, defect or failure, one another same. Okay, defect. Yeah. Okay.
Yeah.
So bugs are found in a testing phase or QA phase. Okay. Then issue. What is issue? Issue, if there is any error in the code, it is called actually issue. Okay. So issue can cause bug. If you don't find the bug, then it is called actually failure or a defect in the production environment.
Yeah.
Okay. So that is the main. It's an interview question. Anyway, very good question. The difference between bug and defect is, failure is, bug we found an issue in a QA environment. If you found an issue in a production, it is called actually defect.
Okay. Yeah. Thank you.
Okay, then we'll catch up on Monday at the same time. There is no class on Saturday and Sunday. We don't have class on weekends. We have classes only on weekdays. Same time you can join. Thank you. Thank you all.
Thank you.
Yes, sir.